Hi, I'm John Mark Wilson, Head of Strategy and Communications at Applied Intuition Defense. Welcome to Nexus Talks, the forum for operators, policymakers, and technologists working at the forefront of our generation's most significant national security challenge, which is delivering AI and autonomy to our nation's warfighters. Today's webinar is our last in a series leading up to Nexus 24, which is Applied Intuition's annual National Security and Tech Symposium in Washington, D.C. This year's event will take place on June the 13th at the Kennedy Center in Washington, D.C. And this year's theme is Accelerating the Software-Defined Force. To help us set the stage for the event, we're going to take the next 30 minutes to talk about software-defined warfare. And then we're going to address several key questions, such as, what do we mean by software-defined warfare? Software-defined warfare is not a new concept, but software capabilities changes with technology. We must continuously evaluate where we are and what these different concepts mean. Critically, what does a software-defined force look like? And also, what barriers, whether they be technological, cultural, or political, stand in our way of achieving our goals? To help us answer these questions, we welcome Bryan Clark, Senior Fellow and Director for the Center for Defense Concepts and Technology at the Hudson Institute. Welcome, Bryan.
Thanks a lot, John Mark.
You can see the details of Bryan's distinguished career and outstanding research linked in the description below. I did want to highlight a few things for the audience. Bryan's a submariner, and so Bryan, I'm a bit of a submarine nerd myself. I love a good submarine movie. Like, what are some of the things that the average Joe, doesn't understand about submarines?
Well, first, it's not submariner. People will say submariner, and that just means you're not a very good mariner. I don't think people like that connotation. So,
right.
Submariner is the right term. I'd say we know submarine movies. I think that's a great question. Das Boot, I think, is probably the favorite of most submariners, just because it captures the real the stress of the job and some of the funny parts of it, and the fact that it's just a very challenging environment in which to operate.
Right.
Other submarine movies tend to ignore the kind of more pedestrian elements of it, but I think Das Boot captures the kind of day-to-day routine that sometimes is the case.
Bummer, I was hoping you'd go for Hunt for October.
Yeah, that's right. Well, that's a good movie, but obviously very, very fantastical. Yeah. Just like Crimson Tide. Nobody's got dogs on boats, and you don't see quite that same. So those situations don't rise very often, but Das Boot's a little more reflective of life in the submarine.
Awesome, thank you. Bryan served in a series of senior policy positions within the Department of the Navy. From 2013 to 2019, Mr. Clark was a senior fellow at the Center for Strategic and Budgetary Assessments, where he led studies for the Department of Defense Office for Net Assessments, Office of Secretary of Defense, and DARPA on new technologies and the future of warfare. Prior to that, Mr. Clark was a special assistant to the Chief of Naval Operations and the director of his Commander's Action Group, where he led the development of Navy strategy, implemented new initiatives in the electromagnetic spectrum operations, undersea warfare, expeditionary operations, and personnel and readiness management. So a long career both as a warfighter, a practitioner, and as a policy leader. So we're honored to have you here, Bryan.
It's great to be here. I really appreciate the opportunity.
Thank you. So we'll dive right in.
Yeah.
So I wanted to begin our conversation with a high-level question. What's software-defined warfare?
Yeah, that's a great question, because I think people throw that term around as if there's something new going on with regard to software and warfare. But in a lot of ways, we've had a software-defined force for decades, right? Back in the Cold War, we had software, computer-operated systems, software-defined systems, radar systems, communication systems, computers inside of weapons. So that's been around for a long time. I think what's changed is the idea of software being used for decision-making. So software is actually being now used to build courses of action. Commanders can employ it to see what's going on in the battlefield. How can I best use the force that's available to me? We see in Ukraine how this gets used every day, right? They're using software and tablets to build out their plans in real time and be able to then implement those plans using communication systems, like Starlink, which are, again, a software-defined radio system that's, in this case, a satellite-based system. So the software-defined warfare has transitioned from just being software inside of hardware to now software is actually managing the fight and then controlling the machine-to-machine communications that then implement the course of action and make the fight happen.
Interesting. One of the things that that you and I in previous conversations have discussed was like John Boyd and the OODA loop, right? So how does that fit into, how does that theory fit fit into what we're describing in terms of software-defined warfare?
Yeah, so as software gets used to help you make decisions rather than just being the implementation of decisions, you can now look at ideas of like John Boyd's OODA loop: observe, orient, decide, act. Most people think about the fact that the OODA loop is just something where you compete for speed, right? I just got to go faster than the other guy. And that's true in one way, but also it's about making the other guy make bad decisions. So ideally, I want the other guy to make decisions that are worse than mine, but also happen faster, so that he rapidly collapses his decision cycle and becomes ineffective. So using software, I can start to come up with courses of action that will undermine my enemy's ability to make decisions. I can start to create deception operations that confuse him. I can start to obscure my operations so he's unable to orient. And then I can also give myself more courses of action so I can decide faster. And I think a lot of times we just think of speed as being the only element that's at play here, and it's really much more about creating better decisions than my enemy, undermining my enemy's decisions, quality and speed, and then also to giving myself more options. And if you use software to define the decision space, you can get more options so you can make better decisions faster.
In a previous conversation, you and I had a discussion about the art of warfare, right? And how humans historically have defined that.
Yeah.
But now we're looking towards software really being the defining element
Right.
of the operational art in many ways. Or is that an overstatement?
No, not at all. I think with the idea of with software being used to help make decisions, we are now transitioning from a time when operational art, doctrine, tactics were being developed just by humans using their experience and subject matter expertise to come up with plans on the fly, to now a time when I can look at the entire decision space available to me. So I can look at what are the forces available to a commander, what are the different ways that we can employ them, run through all the possible options, and come up with a set of best courses of action that you could employ. So operational art is moving from being something that humans do in advance of conflict to now operational art is something that I can actively employ during a conflict. And in a lot of ways what this is showing is that software is defining our tactics, more than just software defining our capabilities. And I think that's the big shift that's underway right now that a lot of people miss, is that software is now changing the way that we employ our forces, as well as how they operate.
Now that we've teased out a little bit about the theory of software-defined warfare, let's now move to the force.
Right.
So with that in mind, descriptively, what should the force look like that has to conduct operations in this new concept?
Yeah, so you think you could take today's military, which is predominantly crude platforms with maybe some unmanned systems that are operating at the edge, to kind of give them longer reach, more persistence, that kind of thing. You could still do a lot with that force if you had a software-defined decision-making capability, right? So you can come up with better courses of action, you come up with better plans, you can come up with ways to undermine your enemy's decision-making. So you could certainly improve your decision superiority with today's force. The problem, though, is that's a limited set of options that you're creating for a commander, because the manned force of today is relatively small and shrinking because it's expensive. Each of those units is expensive: a ship, an aircraft, a troop formation. If you want to give your commanders of the future more options, we're going to have to disaggregate that force further, and that means getting down to smaller units of issues, smaller individual distributed units, and that might mean a lot more unmanned systems, because I can't scale a set of crude troop formations at the same way that I can scale a bunch of unmanned systems, because those troops are very expensive to keep because of people cost money, training costs money, recruiting retention costs money. Unmanned systems, even though they have people associated with them, I can have a lot of unmanned systems being controlled by a small number of people, and I can add more unmanned systems without adding more people. So the scaling is what's actually the big difference, and by scaling the force to more distributed force with a larger fraction of unmanned systems, now I can give my commanders a lot more options, because my computer-based decision-making tools can now explore a much larger option space. I've got lots of ways to mix and match the force. If I've got a bunch of unmanned systems, they can be configured differently. They can be heterogeneous. Some can be sensors, some can be shooters, some can be nodes that help me to communicate with each other. I can combine those a lot of different ways, give my commanders more options, which helps them make better and faster decisions, and also makes things more complicated for the enemy and slows down the enemy's decision-making cycle. So getting to that more distributed and more disaggregated and heterogeneous force is really where the department needs to go if it wants to take advantage of software-defined warfare.
Great. And so with that, what are the implications for hardware? Because we think
Yeah.
very much a lot when military capability at least throughout all my military career, was very much focused through the lens of hardware.
Right.
You mentioned in a previous conversation that hardware is going to become commoditized.
Right.
What does that mean?
Yeah, so I mean, you're already kind of seeing this shift where hardware is much less important to the performance of a system than the software that's on it, right? We see that already with our commercial electronics, our cell phones, our tablets, our computers. The software that rides on it is becoming much more important to its performance than the underlying hardware. We're seeing the same thing in military systems, where the newer generation of military systems, the hardware in a lot of cases is drawn from the commercial market. The software that rides on them is actually what provides that level of performance, that sensing capability, the decision-making capability, the autonomy that allows them to be able to be effective. So you're seeing on the one hand, just the trend in materials overall is that we're moving towards a set of electronics that are using commoditized hardware with really bespoke software that can be defined and changed on the fly to support a particular mission. That's also a necessary element of getting to the scale that we need. So if we want to give commanders more options that their decision-making tools can help them exploit, then we need to have you'll be able to buy things at scale and without having the enormous cost that comes from buying specialized electronics at scale. So I need to be able to buy commoditized hardware, put bespoke software on it, and then give my force that heterogeneity that gives my commanders a lot of options.
That's right. And so what I hear you saying is basically for a commander to fully reap the rewards of software-defined capabilities in his or her formations, you have to give them like the complete suite of tools.
Right.
And that software provides greater flexibility.
Right.
You could do more things if you're able to interchange software.
Right. The software allows you to help make decisions using that broader array of systems, because a human by himself with a planning staff couldn't even exploit all the options possible with this larger force.
Right.
So to take advantage of that larger force, you have to use the computer tools. But to get to the larger force, you've got to take advantage of commoditized hardware and bespoke or specialized software.
Take a quick break. We're going to hear from my colleague Hugh Zabriskie, who's a product manager of Applied Intuition Defense. And he's going to talk to us a little bit more about his views on the mobilization of the software-defined force. And you've done a lot of study and research and thought leadership around this topic. Hugh's going to tell us a little bit about it, and then we're going to pick up there.
Awesome.
Okay.
Thanks, Jam and Brian. At Applied Intuition Defense, our focus is on accelerating the software-defined force. So how do we do that? It all comes down to speed. As Brian covered, speed is the competitive edge in software-defined warfare, where the ability to outpace an adversary's decisions is more important than ever. And that advantage depends on being able to deploy trusted software quickly. We measure speed with 3 KPIs. The first is scale. Achieving affordable mass on the battlefield requires deploying and updating hardware on a scaled mass of systems. We're no longer updating tens of systems, but thousands. So the question is your software development infrastructure designed to support thousands of systems? The second KPI is flexibility. Operational data may not reflect training data, and we need the flexibility to rapidly retrain AI when that happens. That domain gap must be quickly and proactively remediated. Systems of systems, like CJAD-C2, will require testing system-to-system coordination. And the third KPI is how do we decouple our hardware and software development? Separating their life cycles is essential because they can move at separate speeds, and we need to let software develop at its maximum velocity. So let's take a closer look at each, starting with scale. Across several programs, the DoD is shifting its vehicle acquisition strategy from tens of exquisite systems to thousands of cheap, attritable ones. That will require the defense industrial base to scale its manufacturing capacity and reorganize its operations to support that. But the true paradigm shift is that defense software will need to be scaled up on its own virtual manufacturing pipeline in order to continuously deploy AI-enabled software to thousands of vehicles. To collect the data necessary, these thousands of vehicles will also need to collect and push data streams back to developers. This presents a host of challenges. We need to tackle how are we going to accomplish that data collection and software lifecycle across many different heterogeneous vehicles, produced from many different programs that don't share common requirements to support that workflow today. Now let's talk flexibility. Put simply, we need to recognize domain gaps will exist between the development and future operational environments. That means AI-enabled capabilities are likely to fail to meet battlefield requirements in a way traditional software doesn't. This is where flexibility in our model development is essential and directly depends on whether our development infrastructure supports that. Can we shift focus to a new objective, new model, new data set or integrate new partners quickly? Modularity will be a core part of that flexibility. We should be able to deploy software from different partners onto a given platform, provided it meets well-defined platform interfaces. This is doubly important for the CJADC2 mission set. Every time there's a software upgrade to one platform, we can't run a full multi-platform live exercise. We'll need to isolate the software across all systems and test them in a joint virtual environment. Lastly, we need to decouple hardware and software development to achieve speed. Automotive OEMs have been going through this transition to reduce their dependence on tier ones and develop their software-defined vehicles faster. The defense industrial base will undergo a similar transition, and it's already started. This involves re-architecting vehicles to support more complex software behaviors and well-defined interfaces that allow for the flexibility we discussed. At the program level, acquisition leaders can leverage the software acquisition pathway as part of the adaptive acquisition framework to decouple hardware and software procurement. Hardware platforms can also be verified for their compliance to modular and open architecture standards.
Thanks, Hugh. So Hugh just shared a framework for how we think about rapid mobilization of software defined force. Do you have anything to add or maybe to push back on here?
Yeah, so one interesting thing about the research we've done and that Hugh's been part of on mobilization is we're moving into a world where we're going to need to be able to mobilize military capabilities after a conflict starts or after a confrontation starts. We're seeing already with Ukraine how a lot of the military systems that we've been giving them in the West to help fight that fight are already rendered irrelevant by some of the countermeasures that Russia has put in place. One great example is JDAMs. Joint direct attack munition is a GPS-guided bomb that you can use to drop on targets, right? So GPS jamming, though, has rendered that weapon incapable of hitting the target accurately. The same thing with the Excalibur artillery round. So, Ukraine is suffering this problem of the weapons they have that were stockpiled in advance of the war are now largely obsolete because of some countermeasures that the adversary has put in place. We could find ourselves in a very similar situation in the West, in the US in particular, if we get into a fight and then try to come at that fight with a bunch of stockpiled weapons that we've built up over the years preceding the conflict. So we've got to be able to mobilize new capabilities once the fight starts. And in a lot of ways, that's going to depend on software, right? Because I can probably stockpile underlying hardware of like commoditized microelectronics. I can probably stockpile some seekers and some warheads. Obviously, those things don't likely change. But in order to, you have to integrate it in a different package, and you probably got to give it a different set of sensors and a different set of guidance systems that largely come from software to be able to adapt to the countermeasures an opponent's likely to field. So this idea of stockpiling or building up the industrial base in advance of a conflict may actually be the wrong answer. You may simply be building into obsolescence because once the fight starts, you get into a move, counter-move competition. And so that's why I thought Hugh's discussion about speed was really important, but it's speed to get adaptability. Mm-hmm. It's not speed just to deliver the product faster. It's I need to be able to go faster in terms of my pipeline because I'm going to have to come up with new ways of integrating and fielding a capability in response to what my opponent does, or maybe in anticipation of what my opponent might do. And then this idea of hardware-software decoupling, I think, is really important because you can see how the hardware might be really commoditized but disaggregated. And then you have to use software both to empower that hardware and then integrate it into a platform like a munition or a missile.
Great. So what I hear you saying is speed, flexibility, and decoupling hardware software are valid. Right. Maybe we should take a look at and maybe less flexibility and more adaptability.
Right.
Yeah.
It's about being able to adapt on the fly, which, if you have a flexible capability, obviously that can help you do that. And if you have a software pipeline or a software delivery platform that allows you to do that, mm-hmm. then you're set up for success. But I think the challenge will come when DoD doesn't have that pipeline or that ability to deliver new software in support of a new aggregation of capabilities. So you got to kind of modularize your hardware and modularize your software to bring it together into a package based on what the situation is presenting to you.
So you and Dan Pat have done some really interesting research on the hedge force concept. So really two questions really. The first one is, can you describe the hedge force, what it is? And then number two, can you give us an example of maybe of where around the world that hedge force could be useful, or where we're even seeing some initial implementation of that concept?
You bet. Yeah. So one of the challenges that DoD has right now is you've got proliferation of technologies. is making it so that adversaries are much more capable than they used to be. So leveling of the playing field, if you will. You can see in Ukraine how Russia and Ukraine have both started to field very advanced systems, drones that take advantage of commercial technology. Same with the Houthis and their attacks against Israel. You can see with Iran, other proxies using these capabilities. So they're definitely leveling the playing field with technology. Also, then, the U.S. is usually the away team in all of these confrontations, which puts us at a disadvantage in terms of capacity. Yep. So capacity is getting leveled, capability is getting leveled, rather. Capacity is getting constrained. And now we're faced with situations where we may not have the force that's able to succeed at acceptable risk in some scenarios. That's a situation the DoD is starting to wrestle with as they do defense planning. And what Dan and I proposed was that the DoD could start to field primarily unmanned hedge forces into regions where we think there's a situation that might get beyond the capability and capacity of our force because of this technological proliferation and because of the geographic disadvantages we have. We think one area where these hedge forces could be most advantageous is in the China-Taiwan fight, right? Mm-hmm. So if we use a hedge force to protect Taiwan from invasion, that would allow us to lower the risk of that scenario for the U.S. force. It would help reassure Taiwan as well as Japan and other allies that we've got their back, that we're able to put unmanned systems into that field to be able to intervene if China does invade. And these forces are essentially they would act as a mobile minefield. So it's not a highly sophisticated operation, but using unmanned systems on, above, and below the water, you could really disrupt and slow down a Chinese invasion of Taiwan and make it so that you might kill some of their ships just outright, but you could also make it so that they're better targets for our long-range fires. So that combination of disruption, slowing, and then better targeting for our long-range fires could make it so U.S. forces, without a lot of changes, would be able to defeat that invasion, and it sort of takes down the risk of that scenario. Yep. So that concept is one we're looking to apply. There's probably other places around the world where those situations might exist.
And I suspect too that a hedge force wouldn't only be useful if the balloon were, God forbid, right, to go up, but also in deterrence as well.
Absolutely, right. So the idea we would have in our hedge force is that it would be deployed in Japan, in the Southwest Islands, and in the Philippines, the Batanes Islands, where U.S. forces are already operating, to some degree. So these hedge forces would sit there, and if it appeared there might be an invasion imminent, you send those the unmanned hedge forces into the Strait of Taiwan. They would stand by to see if China decided to make a move on Taiwan, and if it didn't, the hedge force would simply come back. And it's a low-cost way to deter, create more complexity and risk for the Chinese, drive their decision-making in directions other than invasion. And it does it without having to totally rebalance the U.S. military to optimize it for the China-Taiwan invasion.
Awesome. Pivoting now towards something that's on everyone's mind, right, which is Replicator. Right. So given everything we've discussed thus far, what advice would you have for the department as it's wrestling with Replicator? We're now well into implementation at this point. But there's still a bunch of work to be done moving forward. So what's your advice there?
Yeah, so John Rick, we thought the hedge force concept would be a great application or use case for Replicator. The Replicator initiative is about delivering unmanned systems at scale in a relatively short time frame. We thought using them in a hedge force to protect Taiwan from invasion would be a great use case for that capability. The challenge I think that they're going to have is in integration, right? So DIU can buy a bunch of unmanned systems that are available from commercial providers, but then you've got to somehow get them out to the fleet or the force, and then you've got to tie them together. You need decision-making tools that help you to do mission planning and then manage their operations once they're doing something in the fight. You've got to have the ability for them to communicate with one another to some degree if they're going to collaborate to create coherent effects. And you've got to have the ability to sustain them over time, which means I need to probably evolve their concepts of operation and evolve their tactics over time to account for Chinese or other adversary countermeasures. So this idea of what happens after you buy the system is really important, and I think the department needs to put more effort and attention into the second phase, basically. Once you've delivered it, how are you integrating and sustaining it over time?
That's great. And I guess really kind of one final question to take us home. The services. The services play a huge role in the right, in the software-defined force. Can you kind of elaborate a little bit more? Kind of talk about areas where they can be very helpful, and maybe some areas where maybe industry should have
Right.
a greater role?
Yeah, so I mean, I think it's a great way to think about this is in terms of like the software factories that a lot of the services have created and some are considering creating. There's clearly going to be situations where the service with, civilian or uniform leadership should be managing a software factory. Situations like electronic warfare system reprogramming, which has to happen in a relatively short time frame. It's in response to intelligence that's been gathered. It's going to go directly into fielded systems, and go out to the force. That's probably inherently governmental. So even though contractors may do support functions for that software factory, it needs to be something the government's managing inside of the decision loop of the uniform leadership, right? So that's going to happen probably out in the field somewhere. But then there's other opportunities where software factories maybe make sense to be an industry. So if you think about software factories are usually associated with like an acquisition effort. And I think that one thing to think about is aligning those software factories with some kind of program manager or PEO structure, because it's primarily there to deliver some kind of product or some kind of support to a product line. And in that case, you'd have a program manager or product, or rather a PEO, who's bringing on an industry support organization to be the running that software factory, so be the operator of that software factory. In that case, I think there's certainly a role for industry to take the lead in terms of delivering the software for the software ecosystem within which a set of capabilities might operate.
That's really interesting, the way that you kind of broke it out from the tactical ground level to the more program level, which is useful. I think one of the things you always hear about from the battlefield in Ukraine is how fast the Ukrainians are integrating technology and integrating software into operations. Are they doing something similar to that?
Yeah, so when you look at the Ukrainians, they are reprogramming their radios and some of their weapon systems, in real time in the field, and that goes along with kind of what I was talking about with electronic warfare reprogramming. That's something that has to happen, out in the force. It's usually led by the uniform leadership, and then you might have contractors doing support to that, but that's really an inherently governmental function. And then I think you've got a separate effort going on in terms of delivering new capabilities and sustaining those that are already in the field, which is more run by the acquisition side of the government. And that again could be a service function, but it's much more about the service acquisition professionals as opposed to the operators.
That's great. Thank you so much, Bryan, for being with us today. It's been a very good conversation, and I look forward to kind of teasing more of this out at Nexus, where you'll be one of our featured speakers.
Thanks, John Mark. It was great to be here. I'm looking forward to it.
Thanks, Bryan. Great conversation. We learned a lot. We look forward to seeing you at Nexus. So with that, we're done. I'd like for everyone, as a reminder, just to, if you're interested in attending Nexus 24, see the link below and register. We look forward to seeing everyone. We're going to talk about software-defined warfare, and we're going to talk about a lot of other topics related to it. So we look forward to seeing you, and have a great day.